Hello students, welcome once again. Before I start, I will request you all, those who are getting benefited with this series, please do like the video and please do subscribe the channel also. Okay, so let's start. The next topic is differential calculus. See, I didn't take the chapters now individually, separately. I've decided to put up two worksheets or two practice sheets on differential calculus, followed by two practice sheets on integral calculus, and then miscellaneous questions. Okay, the practice sheets on miscellaneous questions. So let's start quickly. So the first question here is the number of solutions in the interval 0 to pi that satisfy this equation. As a one more thing, one more suggestion or request, whatever you take it, whatever you feel like it. See, my point is that you all must try the questions that I am uploading as PDF as on the post of this of the channel. Okay, so you must try those questions before watching the video, before watching the solutions. Okay, and if someone is getting this video directly, I mean those who haven't subscribed the channel, for them of course you should go through the question, pause the video, try to solve it, and then if required watch the solution. Okay, so see, that's not a difficult question though. But then the format of the question, as I always say, those who are regularly watching my videos, they must be knowing that my one of the focus is also the format of the question, because as I always say that in JEE Mains and JEE Advanced, there you will find so many questions which look very different, very new, very typical, but when you once crack the question, they are really a simple question. Okay, I think the same is the case here. So I can write it as log of tan x 2 times to the base 3, isn't that? How? Because we know if you have power over the base, then that appear in the denominator outside the log. Okay, so power is half, so in the denominator if you put half, so you get 2 in the numerator. Now that's one term into, so what is it? So this is, see, again I can write it as log of root 3 whole cube to the base root 3 plus log of 3 to the base tan x whole within square root is equal to minus 1. As a one thing, the moment you read this equation, see, we all should remember and we all should know that of course this is a square root, it will always give us only positive value. So if the product is going to be negative, the only thing which has to be negative is this one. Okay, so this has to be negative. One thing that we need to keep in our mind. Now, what can I write for this? This is 3. Plus, see, normally we prefer to have constant base in the log term, and moreover, if you have more than one log term in an equation, in an expression, in the inequality, in any such a statement, okay, what we prefer is to have all the log terms over the same base. So since this is to the base 3, I will like to write it as 1 over, so changing the base and the input, interchanging them. How? By reciprocating the log. So I can write it as log of tan x to the base 3, and this is equal to minus 1. So I will say, okay, squaring both the sides. So this is nothing but 4 times log of tan x to the base 3 whole square. Okay, so I just squared both the sides. Now see, we all know what am I going to do. So I will say let log tan x to the base 3 be some variable p. So put this value here. So it's 4p square into 3 plus. So it's 4p square into 3 plus 1 by p is equal to 1. So just try to simplify it. So what do we get here? So just a minute. Okay. So we will get it as 4p square into 3p plus 1 by p is equal to 1, since p can't be 0. Okay. Log of tan x to the base 3, in that case tan x has to be 1. Okay, but then see, tan x can't be 1 because it was there in the as the base, and we know base can't be 1. Okay, so this won't be 0, so we can easily cancel it. So now this is nothing but 12p square plus 4p minus 1 equal to 0. Okay, so yeah, it's middle term split method, we can easily use it. 6p minus 2p minus 1 equal to 0, so take 6p common, 2p plus 1 into minus 1, 2p plus 1 equal to 0, so that's minus here. Okay, so now we got two roots here, p as minus half, p as 1 by 6. So what is p actually? So P is this, so this is equal to minus half. So what does that mean? So that means tan x is nothing but 1 by root 3 if I am not wrong, bacho, isn't that? And the other point is, other possibility is 1 by 6. So that means tan x is equal to 3 raised to the power 1 by 6. Now as I said, see, we have squared both the sides. So we should always remember, when you are squaring both the sides while solving an equation, you may get extra roots. We call it extraneous roots. Okay, so it may happen that we get extra roots. So what we need to do, okay, there are two cases, there are two possibilities, or there are two ways to handle that situation. One is, before squaring both the sides, we should ensure the sign, okay, and use the condition of sign. But for me, the easier thing is solve it, squaring both the sides, solve the equation, get the roots, and then go back and check the roots to the in the original equation. Now as I said, this has to be negative, because this into this is a negative number, and second term is a square root which can't be negative. So in any case it has to be negative. Now log to the base 3, so 3 is greater than 1. So when will that be negative? So it will be negative when the input is less than 1. Tan x has to be less than 1, because log 1 to the base, or log 1 to any valid base, is 0. Okay, so if base is greater than 1 and log term has to be negative, so input has to be less than 1. So which input is going to help us? So that's the input which will give us the answer. And in the interval 0 to pi, first quadrant, second quadrant, tan x is positive in first, negative in second. So it's not going to repeat the value in the first two quadrants. So if it's tan x is equal to 1 by root 3, of course we know x is pi by 6. So that's the only possible solution. So answer is, it has only one solution here. So that's it. So moving to the next question. Next question is, fx is x cube minus 2 times mod x. Then we have to test for the continuity and differentiability of g of x in the interval minus 2 to 3, where g of x is defined like this. Okay, so what is g of x? G of x is nothing but minimum of f of t when t lie between minus 2 and x. Both the end are closed. Okay, both the end are closed, and at the same time x lie between minus 2 to 0. But remember, this is open end, x is less than 0, x is not equal to 0. Okay, and then in the second step, or gx is maximum of f of t when t lie between 0 to x, both ends closed, and x is between 0 and 3, again both the ends are closed. Okay, now see, that's a very common type of question for advanced level paper. Okay, so that's why I picked up this question, so that all of you should have at least an idea, or should have gone through such type of question once. Okay, how do we start it? So if I have to solve it, of course I am solving it here. Okay, so I think those who could solve it would have tried the same method. We draw this curve, y is equal to x cube minus 2 mod x. So we know how to draw it, isn't that? So what's the curve here? So it's the roots are x is equal to 0 and x is equal to mod of if I take it as wait, okay, plus minus root 2, no? So if I, for x positive, if I write it as, so it's x cube, x common, x square minus 2 equal to 0. So x 0 of course, and x is equal to root 2. So something like this. And for x negative, it will be x cube plus 2 mod, or 2x. So again x is either 0 is the common case, and then x square plus 2. Okay, I'm sorry. In that case it will be plus 2. Okay, so x square plus 2 can't be 0. So that should be the answer, isn't that? I mean, that seems to be the case. Wait, when x is negative, so function is f of x is x cube plus 2x. Okay, so x is either 0 or it has no, okay, right. So something like this. Wait, it's an increasing function. It's an increasing function. That will be the curve. Okay, that was the mistake which I was going to do. So because it's a cubic polynomial, okay, with the leading coefficient as positive, so it has to start with minus infinity. Okay, that's the same idea. So I had the same bias here. I was going to take the mirror image. Okay, so that was the mistake I was going to commit. Anyways, That's the curve of y is equal to f of x, bachcho. So that's the curve of y is equal to f of x. Now see, I will take it as t, and this is of course as y. So I am saying now, I am claiming that this is the curve of y is equal to f of t. Why? Because see, in the question where we need minimum of f of t, t is the variable of the function, where t varies from -2 to x. Okay, so let's say this is our -2, 0, √2, and it goes till I think 3. Yeah, it goes till 3. Okay, now function says that g of x is minimum of f of t when t lie between -2 to x and x lie between -2 to 0. Okay, so that means t can't exceed 0. Now t the lie between -2 to x, so there should be somewhere is x. Now tell me, where do we have minimum value? It's an increasing curve. It's an increasing curve. The minimum value is at this end, -2, and it's the closed end. So f of -2 is the minimum value till you go till 0. Am I clear or not? See, it's an increasing curve. Increasing curve takes the minimum value at the left end of the interval, and for any x that lie between -2 to 0, 0 excluded. For any x that lie between -2 to 0, okay, the left end for t is fixed, which is -2. Okay, so at the left end it has minimum, so that means this is nothing but f of -2. So how much is it? So how much is it? -12, whatever, minus. So that's a constant function. So this is nothing but a constant function like this, open at 0, because 0 is not included here. Now let's move to the next part, which says g of x is maximum of f of t when t is between 0 to x and x lie between 0 to 3, 0 included, 0 included. Now when you come here start from here, okay, so t goes from 0 to x, so that's x. Maximum value is what? Of course, again, that's a decreasing function till this point, and after that also it's always negative, below 0. So from 0 to x till you reach √2, it's 0. The maximum value is 0 because the entire curve between 0 to √2 is negative. So in comparison to any negative value, 0 is the largest value. Okay, so this is going to be 0 here till √2, till √2. Now when you cross √2 from here to here, x, the maximum value is at the right side, because now it's an increasing curve. For increasing curve, when t varies from √2 to x, the maximum occur at the right end of the interval, and for every x the right end is at the x only. Okay, so this is equal to 0 when x lie between 0 to √2, and this is f of x when x lie between √2 to √3, sorry 3. Okay, now see, √2, at √2 the function is like a continuous function. So how does the curve look like? So the curve of y is equal to g of x looks like something. So it's here a constant from 0 to √2, and from here it's not like that, of course, it's a cubic curve. I'm sorry, this is √2 and something like this. How many points of discontinuity? There is only one point of discontinuity, which is x is equal to 0. So at the point of discontinuity we have non-differentiability. So at 0 and √2 we can directly see the sharp turn at √2. Okay, so we have points, these are the points of non-differentiability. So there are 3 such points whether the function is either discontinuous or non-differentiable. Okay, so that's it. So that was the question. I believe you all would have understood. If there's any doubt, I will suggest you all to pause the video in between, try to understand it, try to solve it on your own, and then if you couldn't, repeat or replay the video. Okay, so that's it for the second question. Moving to the third one here. Now see, that's your third question. It's a question of limit though. But I think the more important aspect in this question is the summation part. Okay, so for me it's more a question of summation series, solving the series type of thing, rather than limit, because limit I don't think will be a problem once we would solve this summation, this series. So tan theta is common. Tan theta plus tan cube theta upon 1 minus tan square theta is the case. Okay, so it is 1 plus tan square x upon 2 raised to the power r plus 1 over 1 minus tan square x upon 2 raised to the power r plus 1 here. Now just look at this expression, bachon. What is it? 1 plus tan, rather 1 minus tan square theta over 1 plus tan square theta. Whose formula is it? So that's our cos 2 theta. Okay, so I can write it as, so therefore this is limit n tends to infinity summation of tan. So since I am going to write cos 2 theta, so I am going to express tan in terms of sine. So it's sine of x over 2 raised to the power r plus 1 upon cos of x over 2 raised to the power r plus 1 into cos 2 theta. This is theta. So it will be cos of x over 2 raised to the power r. I think all of you will agree. Okay, if this is theta, you multiply it by 2, one power in the denominator will get reduced. Okay, now see, the interesting thing is, try to understand, 1 by 2 cube minus 1 by 2 raised to the power 4, I am writing it randomly, is nothing but 1 by 2 raised to the power 4. That's a very interesting thing. What I mean to say here is, in general, 1 by 2 raised to the power n minus 1 by 2 raised to the power n plus 1 is nothing but 1 by 2 raised to the power n plus 1. That's what I am going to use here. How? So this is limit as n approaches infinity summation of, I will write sine x upon 2 raised to the power r plus 1 as the difference of these two. So sine of x raised to the power 2 raised to the power n minus rather r minus x over 2 raised to the power r plus 1, and then you have cos of both these angles as product. Isn't that, bachon? Now we all know what to do. We are going to use cos a sine a minus b formula, and then we could write it as difference of two consecutive terms. So sine a cos b, so I am writing it quickly, this into cos of x upon 2 raised to the power r plus 1. So that gets cancelled, and here you are left with x upon 2 raised to the power r. Similarly, minus cos of that gets cancelled, and sine of x over 2 raised to the power r plus 1 over this gets cancelled, cos of x over 2 raised to the power r plus 1. So what is it actually? So this is equal to limit as n approaches infinity summation of tan over x raised to the power 2 raised x upon 2 raised to the power r minus, so consecutive terms, isn't that? So once you have to solve the series, so what are we going to do? So this is nothing but limit as n approaches infinity. Let's go on putting the value of r. So r starts from where? 0 to n. So that's our f of x. Okay, f of x. Yeah, we have x. Sorry. So just put the value. So tan x. So it's x minus tan when you substitute r by 0 plus tan of x by 2, substitute r by 1 minus tan of x by 2 square. Okay, so in such cases we know we are left with one term as the positive term in the beginning. We will be getting only one term at the last with negative sign, with the opposite sign, that is negative sign. And if we got the first term by putting r is equal to 0, we will get the last term by putting r is equal to n. So what are we going to get here is limit as n approaches infinity tan of x minus tan of x upon 2 raised to the power n plus 1, replacing r by n here. Okay, so it's n plus 1. Now as n goes to infinity, this is independent of n, remains same, and this is 1 by infinity is x by infinity is 0, so tan x. So now we know tan x by x is 1, isn't that? So fx by x, this has to be x tends to 0, so that's the answer. Okay, So as I said, that was more a question on series than the limit, but still it's fine. I mean, still deliberately I left this question, I kept this question because see, we have a mix of the question. That's what we are expecting in our advanced paper. Now these are 4 questions of limit, almost similar, but then how to approach it. Okay, so the first one is limit as n approaches infinity 3 times n factorial over n raised to the power 3n whole raised power 1 by n. Now see, first thing is we try to figure out which indeterminate form is it. If at all it is an indeterminate form, okay, because then only we expect to use or we try to use any method there, bachcho. Okay, so let's try it. So see, n factorial. So if I just write n factorial as 1 into 2 into 3 into dot 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 n minus 1 into n. How many n as product we have? We have n square into n. Okay, isn't that? No, rather n cube. We have n cube. Okay, so n into n, how many times? 3n times. Okay, so we have, even if we put here n under all these numbers. Okay, so but for the last number, if I even put here n square, n square, n square, n square. Okay, then also what are we expecting here is wait, see, my point is they are all approaching 0, isn't that? They are all approaching 0. Okay, and the last term, since we have more than 3 times more n in the denominator than the number of terms as product in the numerator, where the numbers are finite, I mean 1, 2, 3, and the last we have few n, I mean the numbers which are closer to n, but in the denominator we have 3 times more n. Okay, so as n goes to infinity, denominator is a very big infinity in comparison to numerator, so this entire thing actually goes to 0. Now 0 raised to the power infinity is nothing but 0. Okay, so without even I mean it's not an indeterminate form, we don't need any method to solve it. See, while solving the question of limit, the first step is to determine which indeterminate form is it. Okay, so that's what I try to check here. So I think all of you would have got it. This is going to be 0 within this the bracket or the base of this expression is 0, and as n power goes to infinity, 0 raised by infinity is definitely 0. Now moving to the next one, where it is n factorial whole cube. Okay, limit as n tends to infinity, n factorial whole cube over n raised to the power 3n into e raised power minus n 1 by n. Yeah, okay. Now see, now here at least one thing is for sure, that you have as many terms as product in the numerator as you have in the denominator. Okay, you have 3n numbers or n, 3n times n multiplied in the denominator. Similarly, you have 1 till n, then 1 till n, 1 till n, again 3n numbers multiplied in the numerator. So here we stand a chance. Here we stand a chance that we will get some indeterminate form. Here we can't say that whether the base is 0, infinity, what. Okay, so that's one thing. Acha, one more thing, as n goes to infinity, e raised to the power minus infinity, if I take it to the numerator, rather what I will suggest is I can definitely take it as 1 by e raised power minus 1. Okay, whole raised to the power 1 by n. So I will take it out of it, then it's n factorial whole cube upon n raised power 3n whole raised power 1 by n. So this is nothing but e times now the limit, okay, L. Now where L is limit n tends to infinity, n factorial whole cube upon n raised to the power 3n raised to the power 1 by n. Normally what we do in this type of cases, normally we go for the log. Okay, so ln of L. So why are we doing it? See, you will realize it quickly. So 1 by n into ln of, now see, 1 by n into 2 by n into 3 by n, n by n and that's its whole cube. That we could have done earlier also. I mean, I could have removed this and put it here. Okay, so anyways, we are going to get the same thing. So ln of L is 3 by n, and of course n tends to infinity, and then I will write it as ln of r by n. R goes from 1 to n, and I know you all now got it. This is nothing but 0 to 1 ln x dx. Isn't that, bachon? You have a standard form. Limit n tends to infinity, 1 by n summation f of r by n. R goes from 1 to n, R goes from 0 to n, R goes from 0 to n minus 1. Doesn't make any difference. This is nothing but 0 to 1 f of x dx. The only thing is, whatever function you have within f, within summation, within f, okay, whatever input you have, that all inputs should be, all the terms in the input should be in the form of r by n only, bachon. Okay, just a minute. Yeah, right, fine. Okay, so that's it. So now just solve it. So we know it's 3 times x ln x minus x 0 to 1. So when I put 1 here, this is minus 1, then I put 0, it's all 0. So it is nothing but minus 3. So L is e raised to the power minus 3, and we have already one e here. So the value of this limit is e into 3. That was ln L. Okay, so ln L is nothing but minus 3. So L is e raised power minus 3. So it is e into e raised power minus 3, which is e raised power minus 2. So it's a match the following. So that matches, the first one matches with 0. Okay, second one matches with e raised power minus 2. Now this one, isn't that the same thing? Seems to be the same thing, bacho. Right? I will take 2 common here. I mean, this power, I will remove here, and this thing, and then taking ln both the sides. So 2 by n, and then the same thing. So it's 2 times 0 to 1 ln x dx e raised power minus 2. So that also goes with it. And then the last one is n raised power 2n upon 2n factorial whole raised power 1 by n. Let's try that. So limit n tends to infinity, n factorial whole square up, wait, what was that? N raised to the power 2n, okay, n raised to the power 2n upon 2n factorial whole raised power 1 by n. Okay, so that's L. So taking log both the side, ln L is limit as n tends to infinity 1 by n ln of. So okay, it will be actually 1 n by 1 into n by 2 into dot 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 n by n into n by n plus 1 into n by 2n. Okay, so what am I going to write here is limit as n tends to infinity 1 by n summation of ln of n by r. R goes from 1 to 2n. R goes from 1 to 2n. Okay, so now R by n has to be replaced by x. So it is ln of 1 by x. Moreover, since the upper limit is not n, it's 2n, the upper limit of the integral will be 0 to 2. The upper limit is going to be 2. So this is nothing but 0 to 2 minus times ln of x dx. Okay, so this is minus times x ln x 0 to 2 minus times 2 ln 2 minus 2, so ln 4 minus 2, which I can write ln of e square, and then 0. Okay, that's gone. So it is nothing but minus times ln of 4 by e square. So ln of e square by 4. Ln got removed, so it should be e square by 4. We have an option, that should be the answer. That's it. Okay, so those were 4 questions based on the similar pattern, but a bit difference in each of them. There's a bit of difference in every one of them. Okay, so let's move to the next question. Moving to question number 5 here. Question number 5 is fx is a continuous function, ab is greater than 0, differentiable in continuous in closed, differentiable in open interval. Prove that there exists at least one c such that. Okay, yeah, that's a very interesting question. See, the reason to pick up such a question is the arbitrariness here. which is involved in starting the question. See, you all would have done such type of question where we start, we use Rolle's theorem or Lagrange's mean value theorem, but not on the given function f of x, but by assuming some function, using some hit and trial, using something we can visualize here in the question, using our instinct, whatever it is. Okay, see, when I got this question, I really tried a lot. I tried, see what I tried, like if I tell you, of course, AB by C square, that take us to the, and C lie in the interval A to B, though that attempt us to take us towards the geometric mean type of thing, but it didn't help. Then what I tried was, I tried something like, I assumed one function as 1 by x, because when we apply, differentiate it, we will get 1 by C square. Okay, and when we apply LMVT in it, so G of B 1 by B, I mean if I apply LMVT on it, so 1 by B minus 1 by A upon B minus A is equal to minus 1 by C square. See, when you simplify it, you get AB by C square. Okay, so something like that we get. But again, there are two things. We can't just multiply it, like I could have this as again f dash c, so LMVT thing, fb minus fa upon b minus a is equal to f dash c for some c in the interval a to b. This is again following the LMVT, but the point is we are using two different functions. Can we ensure that both of them follows the theorem LMVT at the exactly same point within the interval a to b? Answer is no. There is no logic using which we can say no, they will follow the LMVT at the same point. Moreover, the bigger trouble was greater than inequality. So these were the things which I tried before I got the solution. Okay, so see how I got the solution. If I will be true to you people also. See, then I went back. I thought there might be some mistake here in the inequality or somewhere. Went back to check the question. There the hint was given. Okay, so the hint was, use this function. If I remember it correctly, because I solved it few days back. Wait, of course we have to assume new function here, f of x, g of x, as fx minus f of a plus some p times x raised power n minus a raised. So that's very unusual thing to start with, really very unusual thing. But still, see, just to share this thing also, that we might need to think so many different type of like concept or expressions, functions to solve such question. Okay, so that's why I then decided to share this question and its solution with you people. Okay, but see, after that also, even if I start with this, it took some time for me to get to the final conclusion. Why? It's not still that easy, if I remember it correctly, because then it was like, assume, start with this function and use Rolle's theorem. Okay, so then I thought, of course, Rolle's theorem, interval is given as a to b, so I have to apply Rolle's theorem in the same interval, given interval a to b, so g of a is 0. So that means, so that gave me the idea, of course, that will help us in getting this unknown p. So g of b is f of b minus f of a plus p times b raised power n minus a raised power n, which is equal to 0, because to apply Rolle's theorem, g of a must be equal to g of b. So p is nothing but minus times fb minus fa upon b raised power n minus a raised to the power n. So therefore we are going to start with this function, which is g of x, which is fx minus f of a minus fb minus f of a divided by b raised power n minus a raised power n times x raised power n minus a raised power n. And then see, since the Rolle's theorem condition is being fulfilled here, the requirements are fulfilled here, so of course we are going to apply Rolle's theorem. So there exists at least one c in the interval a to b such that g dash c is equal to 0. So let's use it. Okay, it's a derivative. So f dash x minus a, that's gone, minus f of b minus f of a over b raised power n minus a raised power n times x raised to the power n minus 1. Isn't that? And this is nothing but 0. Okay, and this is true for some This is true for sum c in the interval a to b. So instead of x I will write c here. Okay, so c here and c here. Yes, now from there I got that idea. See, n minus 1 I already have. So what I wrote there is, so that means f of b minus f of a, I'm taking it that side, okay, upon b raised power n minus a raised to the power n is equal to f dash c over 1 by n into c square n minus 1 by 2. So once I got it, c square raised to the power n minus 1 by 2 into f dash c, and this expression is also there, then now that was the hint for me. Okay, so we all know that we can write b raised power n minus a raised power n as b minus a into b raised power n minus 1 plus b raised power n minus 2 into a, b raised power n minus 3 into a square, and so on till a raised power n minus 1. Okay, so therefore f of b minus c, I was now after that I was just trying to get that form. Okay, so I wrote it as replace this thing by this and b minus a, and took all the rest term after cross multiplying to the right hand side. So b raised power n minus 1 plus b raised to the power n minus 2 times a, and dot 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 till the highest power of a over c square raised to the power n minus 1 by 2 and f dash c. Now the only thing is inequality, and the second thing is replacing it by AB. Okay, now see, I applied, since we have n here and we have n terms here. Now the last thing that struck my mind, that helped me to think, was why are we given both are positive? Of course, AM, GM. Okay, n terms in the numerator as sum and divided by n. So apply AM, GM here. So if I apply here, so sum of all the terms upon n is greater than equal to, the product, when you multiply them, what do you get? So b sum from 1 plus 2 plus 3 till n minus 1, a 1 plus 2 plus 3 till n minus 1, how many terms? 1 by n. Okay, now the sum is nothing but b n into n minus 1 by 2, a raised power n into n minus 1 by 2 whole raised power 1 by n. So this is nothing but a into b raised to the power n minus 1 by 2, and then I can replace this whole thing, and this is greater than or equal to. Okay, so we got it. So this is greater than or equal to ab and upon c square raised to the power n minus 1 by 2 into f dash c. So this assumption was really quite unusual. I mean, for me, I will say it was very unusual. I don't know where I could have been able to think this thing or not. Okay, because no, it's not like I didn't think on it. I spent some time on it, maybe half an hour or 30-40 minutes thinking how to do it. That's why I could think about this thing. I could imagine about the GM, geometric mean of A and B, something like that. Okay, but then I thought that there might be some typing error here. Hence I decided to just check the question, and there I found the hint. Okay, so that was the question number 5. Now moving to the 6th one, f dash sine x. So we are given f dash of sine x is less than 0. Acha, x is between 0 to pi by 2. So that means sine x in the interval from 0 to pi by 2. Y is equal to sine x. Sine x is an increasing function, and f dash of this is less than 0. So f of t is a decreasing function. I think all of you will agree. Okay, I think is that okay? So f dash sine x is less than 0. So if a derivative is negative, so the function has to be decreasing, and since the input is increasing, there's not going to be any change in the nature of the function. Okay, but increasing of increasing is increasing, but increasing of decreasing or decreasing of increasing function is a decreasing function. So increasing, I mean, we are talking about composite function. So increasing of increasing is increasing, decreasing of decreasing is also increasing. And if we use both I of d, d of I, it's a decreasing function. Okay. Now f double dash sine x greater than 0. So doesn't that imply f dash sin x is an increasing function? I mean, I don't know where am I going to use it, but fine, that's what we can understand from here. So if the second order derivative of a function is positive, of course the function is an increasing function, and from here, since sin x is an increasing function, so we can say that f dash of t is also an increasing function. That's what I was trying to say there. And g of x is f of sin x, so g of f(x) is f of sin x plus f of cos x. X belongs to 0 to pi by 2, then gx is decreasing. So for increasing, decreasing, without thinking anything, without thinking twice, we know we are going to just differentiate it with respect to x. So what do we get? We get it as cos of x f dash of sin x minus sin x into f dash of cos x. Okay, fine. Now we know that f dash of sin x is what? Negative. And x is between 0 to pi by 2, 0 to pi by 2, both sin, all trigonometric ratio in the interval 0 to pi by 2 gives us only positive values. Okay, so everything, rest of the things is positive. And f dash cos x, what about this? Won't this also be negative, bachcho? Why? Because see, the input is not, the input in this case or this case is between 0 to 1, 0 to pi by 2, doesn't make any difference, isn't that? So input in both the cases is same, 0 to 1, okay, but sin x is increasing whereas cos x in the interval 0 to pi by 2 is decreasing function. So this is y is equal to cos x. Now f dash is an increasing function, so f dash cos x is a decreasing function. Okay, now for this to be decreasing, what are we actually looking for is less than 0. Acha, one more thing. So to get to solve inequality, if we get the solution for equality is the best case. Now for that actually we know that this is equal to 0 at x is equal to pi by 4. So pi by 4 is going to be the breaking point for in the interval 0 to pi by 4, 0 to pi by 2, about which the increasing decreasing going to get decided. So one thing is for sure, the function is going to be either increasing or decreasing in the interval 0 to pi by 4, and the other one in the it's the complementary interval pi by 4 to pi by 2. Okay, so that's what we have to do. But we are solving it for, what are we looking? Cos x into f dash of sin x is less than sin x into f dash of cos x. Okay. Now, okay, so cos x is positive, this is negative, fine, and then, okay, this is positive. So, overall, this has to be negative. F dash cos x is a decreasing function. At 0, okay, let's try. At 0, g dash of 0. What's the value? At 0, f dash sin x is always negative, but f dash function is an increasing function. This is an increasing function. So it will be cos 0, which is 1, f dash of 0, that's it. Okay, fine, and it's an increasing function. Okay, and g dash of pi by 4, if we can see the sign change, that's of course is 0. Okay, now can we say anything about f dash 0? It has to be actually negative. That's, I think, yeah, we are done. We are done, because f dash is always negative, so f dash 0 is also negative. In the interval 0 to pi by 2, closed interval 0 to pi by 2, f dash is always negative, less than 0. Okay, and f dash 0, of course, in that case has to be negative. Okay, and g dash of pi by 4 is 0. Okay, so it's going from negative to 0. So that means g dash is negative in the interval 0 to pi by 4. Okay, now if I try for g dash of pi by 2, let's check it. G dash of pi by 2 is 0 minus sin x into f dash of 0. And again, yeah, we are done, because f dash 0 is negative. Okay, so negative makes it positive. So that means from 0 to pi by 4 is negative. At pi by 4 g dash is 0, and from pi by 4 to pi by 2 is positive. We have only one point at which g dash is 0. So of course on one side it has to be negative, on the other side it has to be positive. So that's it. So that means the function is decreasing in the interval 0 to pi by 4. That's the answer here, bachcho. Okay, so that's it. I think all of you will agree to this, and if anyone has any better solution, I will say let me know that. So 1 plus f of x. So fx is a polynomial function with degree n such that, see, I tried to solve this question. I mean, I solved that question, of course, as a doubt here in the campus. I will just suggest you, because when I feel that it's going to be a lengthy one, so I will suggest you how to approach it. You try to solve it, you don't get it, then you tell me in the comment box. Okay, I will help you out there. See, 1 plus fx. So the best thing I thought was to start with, of course, x is power n, an minus 1, x is power n minus 1, an minus 2, x is power n minus 2, so on and so on, and the constant function, constant term as b. Okay, so LHS is the entire thing. See, then I tried, see, that's what I thought. Let's proceed with that thing. And since it's a polynomial form equality, so it has to be true for all x, so hence we can compare. At last, what are we actually going to do? We are going to compare the coefficients of same degree term on both the sides. So that will give you the condition. Okay, so what condition are you going to get here is, you will get something like n minus 1 c2. So I think from there it starts is 0. That's the first condition, or n minus 2 c1, something like that. I mean, you try to do it. Okay, see, a and n will match, because when you open it, so it will be an x minus 1 raised power n plus a n minus 1 x raised minus 1 raised power n minus 1, and so on, plus a n x plus 1 raised to the power n a n minus 1. It won't be that difficult as it seems to solve divided by 2. B, the constant term will be same. The only difference is you have plus 1. Okay, so anyways, when you solve it for an, you will get exactly same thing. For an minus 1 also, you will get the same thing. The only difference is you will have to see, I mean, from here onwards, you will start getting this type of thing. Okay, this is 0 when n. So from there, you get the value as n is equal to 2. So just try it, bachcho. I will suggest you to try it. Okay, because see, this coefficient, I mean, this binomial coefficient can be 0 in just two possibilities. Either the subscript is negative or superscript is less than subscript. That's it. Okay, so n minus 1 is less than 2, so n has to be less than n minus 1, so n has to be less than 2, less than 3 in that case. Okay, so it has to be 2 or 1. That's it. Okay, so for 1 it satisfies, for 2, so 2 is the degree in that case. But you just try it, solve it, you will get it. Okay, next is fx plus fc. Again, here again, there's a method, there's a very set method to approach this question, which I always follow. Again, if anyone come across any alternative method, you can think of that method, or you know any such other method, you can, you are of course most welcome to share it with me. See, in that case, what I try is replace x by, first try to interchange. So that's what I always do, first thing. So what do I get? 1 upon 1 minus 1 upon 1 minus x, isn't that? So here also 2 into 1 minus 2 into 1 by 1 minus x. 1 by 1 minus x into 1 minus 1 by 1 minus x. That's it. Now simplify it. So f of 1 upon 1 minus x plus, when you simplify it, you get it as f of 1 minus x minus 1. So x minus 1 by x is equal to, let's say, g of x. I mean, you can simplify it and then we will get something, an expression. Okay, now if this would have been an easier direct question, so normally what happens is if you interchange, you get back the same function. But here in this case, that won't even have helped, or I mean, that won't even have helped, because then see, the target is to get f of x. So what I always see at it is this is one variable, this is another variable. So fx is a, this is b. So two equation, two unknown. Eliminate b, you get a, which is f of x. That's the idea. That's the idea. Okay. But here, since I got it, see, that's how I started. Okay. Then I thought, With what shall I replace x to get something as t, the simple variable t here. Okay, so for that I just, to get it, how I started, I thought, okay, let us assume s to be t, that's it. Get x from here. So 1 is equal to t minus tx. Okay, so tx is t minus 1. So x is t minus 1 by t, that's it. So what does that mean? If I replace in this expression, I mean in this relation, x by t minus 1 by t, we will get t. So doing that, so replacing x by, so what am I going to do? I am going to replace x by t minus 1 by t. Or you can say x by x minus 1 by x, like what I did here. I replaced x by 1 upon 1 minus x, because it's true for all x except 0 and 1, of course, because in that case denominator is getting 0. So that's it. So now do it. So f of this will be x minus 1 by x plus that will give us x, and then again you have some h of x. Replace wherever you have x by x minus 1 by x. Okay, now we have 3 equations in that case. First one is fx plus p of x. Second one, which we got after replacing, thus x by 1 upon 1 minus x. This was I defined it as g of x, right? Now see, try to use them in a way so that we could eliminate this thing and this thing. How? Right, add them and from there subtract this. Add them, so we have 2 fx, and subtract, so this get cancelled with this, this with this. So we have nothing but h of x plus p of x minus g of x. That's it. So you get f of x, and once you have f of x, you know whether it's an even function, it's an odd function, it's a many one, it's a one, everything you know. Okay, so that's normally see, that's the method which I use. That's the method which I use here, bacho, and then you can solve it out. So that was 8th question. Moving quickly to the 9th one. fx is a polynomial of degree 4 with real coefficients such that 0 has satisfied by 1, 2, 3 only. What does that mean? It's a 4-degree polynomial and it can't have just exactly 3 real roots. Okay, even degree polynomial need to have exactly even number of real roots, because imaginary roots always exist in conjugate pair for real coefficient, real polynomial equation. Okay, so it's a real polynomial equation with exactly 3 roots. That means at least one of them has to be repeated root. So if I assume, let's say 1 is a repeated root, doesn't matter. I mean, you can say how do we know that leading coefficient is 1? No, I'm not assuming it. Let's say leading coefficient is 8. That's it. Okay, now if anyone is a repeated root, that means it will be the root of its derivative also, isn't that? That's it. So either this is 0 or this is 0 or this is 0. In any case, answer is 3 by 100. A very simple direct question. Okay, but again, okay, I think you all would have still enjoyed that question. It's a very crisp, simple question. Now, the integer n for which this limit unknown, for such type of question, I will suggest you people. See, first of all, I will write cos square x as 1 plus half plus cos 2x by 2. Okay, otherwise see, it's for me it's sure that I'm going to use series expansion for cos x for e raised to the power x, and that's it. Okay, then minus cos x is fair enough, minus e raised power x into cos x, of course, plus e raised power x minus x cubed by 2 upon x raised power n. Of course, this has to be x goes to 0. I'm sorry, x goes to 0. It has to be 0 by 0 form. Just try it, 0 and then it is 1 and 1 0 0 0 0 by 0 form. Now 0 by 0 form, see, the entire question is based on one simple direct concept which says if for 0 by 0 form, if you have algebraic function in both numerator and denominator, it will give us the non-zero finite value only and only when The lowest degree term in both numerator and denominator is same. In denominator you have only one degree term, that is x raised power n degree term. So that means the lowest degree term that remains after opening the entire all the functions using series, the lowest degree term that remains, let's say that square, second degree term remains, that means n has to be 2. If the cubic term is the lowest degree term, after opening the series cancelling out the terms which get cancelled, cubic term is the lowest degree term which remains, that means n has to be 3, as simple as that. Okay, so if I just try to open it, I mean trying to write few steps, of course needs lot of patience to write all the steps. So I'm not saying that I don't have that much patience, but just still, I mean laziness is always there, no? Half times cos 2x, so it's 1 minus 2x whole square by 2 factorial plus 2x raised to the power 4 by 4 factorial dot 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 minus cos x 1 minus x square by 2 factorial plus x raised to the power 4 by 4 factorial dot 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 minus plus minus e raised power x 1 plus x square by 2 factorial x cube by 3 factorial dot 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 cos x 1 minus x square by 2 factorial x raised power 4 by 4 factorial dot 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 minus e raised power plus e raised power x 1 plus x square by 2 factorial x cube by 3 factorial dot 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 minus x cube by 2, I believe, yeah, whole divided by Now let's see if we can cancel out few terms. 1 half and half is 1, so this and this gets cancelled. Okay, minus 1 plus 1 gets cancelled, the 1 is gone. Now next is linear term. Linear term we have from here x, that's it, that's the only linear term here. So it's actually minus x plus x, that's also gone. Second is, see, we are just seeing that which terms get cancelled. So next is x square terms. So x square term is here, which is x square minus x square, 4 by 2 and by 2. So this is minus x square plus x square by 2. Here we have minus x square by 2. Then we have plus x square by 2. Then we have plus x square by 2. So this is gone, this is gone, this is gone, this is gone, this is gone. X square is gone. Cube. We don't have any cube term, we don't have any cube term. Here we have one cube term, x cube by 6. There's one more possibility, minus x square by 2, rather it's minus x cube by 6 plus x square by 2. Then it is plus x cube by 6, that's gone, minus x cube by 2, okay, that's also gone. Next is 4. Okay, so I think 4 will be the term which will be left with. I mean, iske aage kahan tak, till what will be solved, isn't that? So just check the answer. 4 is an option, 3 is also an option, 5 is also an option. See, that's gone, that's gone. Okay, so like that you can continue. I think 4 should be done. Now you can check it. Okay, so the least degree term which remains in the numerator will decide it. As simple as that. Okay, so now moving to the next one. Actually, I was expecting 3 or 2. Okay, I didn't get it. Now see, moving to this one. See, for such an expression where I have root within root, algebraic form, root within root, I try to write it as perfect square form. Now you just check it out there. 8x minus 16, okay, I thought something, I did it, wait, whose perfect square can it be, bachcho? Okay, if I multiply and divide by 4, isn't it? Let's say. So Now that's it. Isn't that? Multiply and divide by root 8. See why I did? Because if this has to be squared, this has to be squared, I need 8x. Okay, so I just wrote it. Now, this is 2. Of course, this is A and this is B. 2ab. So 8x. So a square plus b square is 8x minus 16 plus 16, and that's 8x. That's it. Simple. Okay, so f of x is 1 by 2 root 2, and x has to be greater than equal to 2. Root of 8x minus 16, it has to be positive. Okay, and one condition is from here also, that we'll see. Okay, so this is mod of, because if I write it as, I will write it as x 4 plus root of 8x minus 16. So there's no need to put mod. Why? Because it's always positive. Isn't that, bachon? Okay, so yeah, I think so. Isn't that? It's a perfect square of a plus b. Right, done. Now similarly, I can write it as 1 by 2 root 2 mod of 4 minus 8x minus 6. Now that could be positive or negative. That's what you have to check. That's it. This will change the sign. Modulus will impact this, not this. Okay. So because of this only, so wherever it is positive, wherever it is negative, that is the breaking point about which we have to decide. But before that, we have to see, we have to ensure that this is also positive, and x is between 2 to infinity. Okay, 2 to infinity, 2 to infinity. I think that in that case, x is greater than, x square is greater than equal to 8x minus 16. X square minus 8x plus 16. So x minus 4 whole square, in that case it's always positive. Done. Okay, so that's it. So now this modulus will make an impact. So this will only decide at how many points is going to be non-differentiable. Discontinuity is out of question here. Why? Because modulus never disturb the continuity of a function. Okay, it may disturb only the differentiability of the function. Now that's another question. X is between 0 to 1, and we have to prove that sine of pi x is less than equal to 4x into 1 minus x. Okay, now few of you may get surprised, how could I simply cross multiply it, or rather in most of the cases I myself say that we should avoid cross multiplication in over an inequality, but since as most of you must have observed, x is between 0 to 1, this is always positive, so it's positive, we can do it. Now how will I start? I will say let fx be sine of pi x minus 4x plus 4x square. Okay, now what we have to prove? We have to prove that this is less than equal to 0 for all x in the interval 0 to 1. That's it. Now to start with, I will just try how much is f of 0. F of 0 is 0, 0, 0, 0. How much is f of 1? Coincidentally, f of 1 is also 0. Now that's interesting. Okay, so what can we imagine? If that means it starts from here, it ends here. Okay, so that means the function at least on the right side of 0, it has to be a decreasing function. Just on the right side of 0, it has to be a decreasing function. It can't be increasing, otherwise it has to get positive. Okay, so now for increasing, decreasing, we know f dash. Let's check. Pi times cos of pi x minus 4 plus 8x. Now again, f dash of 0 is pi minus 4, which is negative. So that's it. So that means f dash 0 is negative, so on the right side of 0 it has to be negative. It can't be jump from negative to positive because it's a continuous function. Any combination of continuous functions is a continuous function. So at least for some interval, maybe how much small it is, it has to be negative. So that means fx is a decreasing function just on the right side of 0. Okay, now can we solve it to get 0? So see, there's only one possibility for which we can think about it is half, because 0 to 1, the only point left is half. Why I'm saying only point left? Because at that point this gets 0, pi by 2. That's the chance. So half, and that's 0. So x is equal to half is the point where it is 0. Now f dash of 1. F dash of 1 is nothing but what? Nothing but what? Minus pi minus 4 plus 8, which is positive. Makes sense, isn't that? Now what's happening? So what's happening is function decreases till half, and on the right side of half it increases, goes back to 1. So comes back to 0 here. Hence it is always negative. Okay, so first it decreases, it starts from 0, goes to the minimum value at half, and then it starts increasing, but could reach only 0 till we take x to 1. Okay, so hence it is always negative, less than 0, and hence sine of pi x is always less than or equal to 4x times 1 minus x. So that's my method to prove it. Now moving to the next question. Domain and range of fx and gx are 0 to infinity, fx be an increasing, gx is a decreasing, h of x. So h of x is an increasing of a decreasing function, hence it is a decreasing function. And also h of 0 is 0. And the range of both the function is 0 to infinity, so hence the codomain has to be 0 to infinity. It's a decreasing function. Okay, so that means hx is universally 0. And for all x, p of x is, how come does that matter? H of x has to be 0. All of you agree or not? Increasing of decreasing or decreasing of increasing function is always a decreasing function. The range of h of a composition actually is decided by the range of the outer function, which is f, and the range is 0 to infinity, so it can't exceed, it can't be negative. It's a decreasing function, h of 0 is 0, and the range has to be positive, so it has to be 0. I think there's some mistake, because then that doesn't make sense. So p of x is actually nothing but 0, because h of 4 is 0, h of anything is 0, so it's 0. There might be some mistake, I'm just skipping it quickly. The equation has 3 equal roots. 3 equal roots. Okay, so if equation is a 5 degree equation, so I can write, so fx equal to 0. So I can write f of x as maybe x minus alpha whole cube into anything, a quadratic, whatever that quadratic is. So see, that means f dash alpha has to be 0, f double dash alpha has to be 0. So just get its second order derivative, f double dash x. It is 20x cube minus 20a cube. Oh, that's it. 0. Great. X is equal to a. We got it. That's the repeated root. That's the repeated root. So x is equal to a. Just satisfy here. So satisfy it here. A raised to the power 5 minus 10 times a raised to power 5 plus b raised to power 4 into a plus c raised to power 5 is 0. Is that a relation anywhere? Minus 9 a raised to power 5. Not at all. Okay, f dash a is also 0. Isn't that? So f dash will be 5 times a raised to power 4 minus 20 times a raised to power 4 plus b raised to power 4 equal to 0. 15 a raised to power 4 is equal to b raised to power 4. Is that so? 5 times a raised to power 4 to a cube into a. Maybe. Acha, oh yeah, that's the answer. B raised to power 4 is equal to 15 times a raised to power 4. Okay. And then see, you can replace this by 15. Okay, so this is minus 9 plus 15, 6. That's the answer. Anything else? Then in the rest of the things also you can try to check it, like you can replace b raised to power 4 by 15 a raised to power 4 and then try it. Okay, so that's it. Moving to the next question, which is the equation has 3 real roots in GP, so let the roots be a by r. Okay, so it has 3 equations, so the product is a cube, which is 1 by 8, so at least we got one thing, which is 1 by 2. So the roots are 1 by 2 r, 1 by 2 and r by 2. Okay, then see sum of the roots. So half common, r plus 1 by r plus 1 is equal to a by 8, so it's a by 4. Taken 2 at a time, taken 2 at a time. Okay, so product will be 1 by 4, 1 by r plus 1 plus r. Okay, which is nothing but minus plus b by 8. It's b by 2. Got a relation. So a is equal to 2b. Okay, now that's has 3 real roots. So if a cubic has 3 real roots, its derivative, which is 24x square minus 2ax plus b. This need to have 2 distinct real roots. So for that, d has to be greater than 0. D is 4a square minus 96b greater than 0. A square is greater than 24b. A is 2b. So 4b square minus 24b is greater than 0. So b into b minus 6 greater than 0. So either b is greater than 6 or b is less than 0. For a is greater than 12 or a is less than 0. See now what are we given? We are given that a lie in the interval lambda 1 to lambda 2. Okay, so that means that lambda 1 to lambda 2 can be anything greater than 12 or anything less than 0. So again B and C are the answers here. So I think that's the last one. So 15 question in this one and maybe another 15 question will be there in your next sheet. So that was the first sheet for your JEE Advanced, the practice sheet from differential calculus. Will be coming up with the next in the next video.